In this lesson, we will see another example of how to solve systems of linear equations using the linear combination or elimination method. The strategy will be the same as it's been in the last couple of videos. We will try to make sure that one of the terms with the same variable in it will be opposites in order to eliminate a variable. For instance, we would want the x terms to be opposites or the y terms to be opposites, so that either the x or the y will be eliminated from the equation. In this case, we're going to find that we cannot simply multiply one of the equations by a number in order to make one of the variables be opposites. We're going to have to manipulate both equations. This is because there's nothing we can multiply 5x by to get negative 6x, so that these would be opposites, and vice versa. I should say no integer value. We could work with fractions, but that's just going to make our life much more difficult. So there's no integer value that we can multiply here, and there's no integer value we can multiply 4y by to get 6y, and vice versa. This means that we're going to have to multiply both of the equations, both expressions of both equations, by some value to make them be opposites. Now, you're going to want to use the least common multiple method to do this. There are many numbers that you could multiply. There are many different ways that you could do this, but if you find the least common multiple of either the coefficients of the x or the coefficients of the y, you'll be working with smaller numbers, which generally is easier to do. Now, since 5 and 6 are consecutive integers, one comes right after the other, their least common multiple will be their product. So the least common multiple of 5 and 6 is 30. So we could multiply the first equation by 6 and the second equation by 5 in order to make this be 30x, and this would be 30x. One of them would have to be negative. Maybe there would be some smaller numbers we could work with if we manipulated the y's. So let's go ahead and find the least common multiple of 4 and 6. Now, you may be able to do this in your head, and hopefully that's the case, but I want to show you exactly how to do this. To find the least common multiple of 4 and 6, you can list the multiples of 4 and the multiples of 6 until you find the smallest one that's in common. So the multiples of 4, you always start with the number itself, and then you multiply it by 2, then you multiply it by 3, etc. So these are multiples of 4. Multiples of 6 include 6 times 1, 6 times 2, 6 times 3, 6 times 4. Sometimes you'll have to go out to several numbers. Sometimes you'll find the least common multiple very quickly. In this case, the least common multiple of 4 and 6 is 12. So we're going to use this, the least common multiple of 4 and 6, in order to make the coefficients of y be 12 and negative 12. So this means I'm going to have to multiply the first equation by something in order to make the coefficient of y be 12. 4 times 3 is 12, so I multiply the first equation by 3. I also need to multiply the second equation by something in order to make the coefficient of y be the opposite of 12, negative 12. So 6 times negative 2 will give me negative 12. So I'll multiply both expressions in the second equation by negative 2. Now I'm ready to rewrite both of these equations, and this time we have to change both of the equations. 3 times 5x is 15x. 3 times 4y is 12y. And remember, that's exactly what we wanted. We wanted the coefficient of y to be 12. Equals 24 times 3 is 72. In the second equation, we distribute. Negative 2 times 6 is negative 12, plus, I should say negative 2 times 6x is negative 12x. Negative 2 times 6y is negative 12y. Notice that our y's are indeed opposites of each other. That's exactly what we wanted. And 30 times negative 2 is negative 60. And now I can add these two equations together. 15x plus negative 12x is 3x. The y's are eliminated, just as we want, and that's going to equal 72 plus negative 60, which is 12. Now I can easily solve for x by multiplying by the reciprocal of the coefficient in both expressions, and I will find that x equals 4. Once I found out what x equals, I can now easily find what y is by simply substituting 4 into any one of these original equations. I'm going to use the first equation, 5x plus 4y equals 24. And I'm going to substitute in x, so it's going to be 5 times, and we found x to equal 4, plus 4y equals 24. Simplify. 5 times 4 is 20. Add 4y, we should get 24. Get rid of all terms without your variable in it by adding the opposite to both expressions. So we're going to add negative 20 to both expressions. These 20s are eliminated. That'll leave me with 4y equals 4. And now we multiply both expressions by the reciprocal of the coefficient, which is 1/4, leaving us with y equals 1. So we've now found that x equals 4 and y equals 1. So x comma y, we put our solution together like this. In this example, we needed to eliminate one of the variables by manipulating both of the equations. And the best way to eliminate one of the variables, the best way to find out how to make one of the variables be opposites, is to find the least common multiple of one of their coefficients.